Hey students, before we begin our next slide on limits, let's start with logarithmic relation. It is very much relevant for the next recapitulation video on limits. So here it is the definition of logarithmic function, how it is read as. Let me first explain that to you. So we define a log function like this and how it is read as. It is log of n, it is log of n on the base of a, and it will be a numerical value. Let me say that value is x. So this is how we read a logarithmic expression. Apart from that, we can also write it simply lg of n on the base of a, and its value is equal to x. If we have log of n on the base of a, which is equal to x, it further implies a to the power x is equal to n, and we have certain restriction on n and a. These are the restriction. N has to be positive, means it has to be greater than 0. A has to be the base of logarithm. The base of logarithm has to be greater than 0, but it cannot be equal to 1. Why it is so? I will leave a PDF link in the description box at the bottom of this video. Now we proceed to some other formulas of logarithms which are very much relevant in the study of calculus in 12th standard. So here we have the first logarithmic relation. It is log of p on the base of a, and we call it base change formula of logarithm. Means we will be changing the base of logarithmic function as per the requirement of the problem as per our choice. So how we do that? If you see on the RHS of this formula, we have log of p on a new base b over log of a on the new base b. Means whatever base needs to be done, whatever new base has to be used, we will simply put that new base, and we will take log of p over log of a, if that is what was given in the LHS. And again we have some restriction, as you can see. Okay, now the next formula is log of p on the base of a. If we have to interchange these a and p, so this will come as 1 over log of a on the base of p. Again we have some restriction. Meanwhile, can you tell me how a and b are correlated? You can drop your answer in the comment section below. Now moving to the third formula, it is called multiplication formula of logarithmic functions, logarithmic relation. Means if we have log of m into n, m and n both are being multiplied, and then log function on any base is applied, so we can simply write log of m plus log of n. For that matter, suppose if we have on any base a or whatever it is, I will not write the base. Suppose we have x into y into z. These are being multiplied and logarithmic function is applied. We can always write it as log of x plus log of y plus log of z. So that is how it works. Let me rewrite it so that you can see it is log of z. Now the next one, the fourth formula is division formula of logarithm. It is log of m over n. So you can see it is log m minus log n. It is very interesting to note that In case of multiplication, here we have to use plus sign. In case of division, here we have to use the subtraction sign, the negative sign. Now moving to the next, it is log of m to the exponent n. This exponent n can be taken out and we can write log of m multiplied with the exponent n. How does it work? Let me show you. Suppose I have log 8. If we rewrite it as log of 2 to the power 3, it further can be written as by using this formula as 3 log 2. So this is how this formula works. Now the next formula, it is log of a to the power p on the base a, that is base of logarithm. So by using the previous formula, the formula at e, we can take this p at the forefront and then we will be left with log of a on the base of a being multiplied with p. So this will be p into 1, that is p. How does this 1 comes? So it is actually another formula. Log of a on the base of a is 1. Keep that in mind. Okay, now we take further to the next formula. Now it is it is very important formula and will be widely used in the topic derivatives. It is a and we have the exponent log of fx. For logarithmic function, the base is a, which is the overall base of log fx. So in that case, we will get fx. Suppose I explain, if we have 3 and then we have log of sin x and the base of log is 3. So it can be written as simply sin x. So this is how this formula works. This h formula has already been discussed a few moments ago. Log of anything on the base of same is always 1. Means, suppose if we have log 5 on the base 5, its value will be 1. Suppose we have log of e on the base of e, again its value will be 1. For that matter, if we have log of 10 on the base of 10, again its value will be 1, and so on. Moving to the last one, we have log of 1 on the base of a. We have log of 1 on the base of a, its value is 0. For that matter, if I give you some other examples, log of 1 on the base of e is 0. Log of 1 on the base of 10, again it is 0. For the proof of these formulas, as I mentioned earlier, I will drop a PDF link in the description box at the end of this video. Meanwhile, you can subscribe to my channel so that you will be notified for the further future videos. Share this video with your friends, hit like button, that motivates me. Bye bye, take care, be safe at home.